everyone. My name is Timothy Lee Grant, and today we are going to be talking about precision and recall. So these two terms are ways which we can judge how good our machine learning algorithm, and in specific, our binary classification machine learning algorithm is. So these are two different metrics, and they will give us a number which lets us kind of understand how good our binary classifier is, but in subtly different ways. Okay, so before we get into that, let's first dissect what is a binary classifier. Okay, so binary means we have two different classes. Now we have a 0 and 1, right? So binary and then classify. Our algorithm is going to output a classification, and it is going to say, okay, given this input, given this data point, I think it belongs to positive or negative. Okay, so that's what a binary classifier is. You give it a data point and it classifies it as either 0 or 1. All right, so that's what binary classifier means. Now, there's something else that we kind of need to talk about, and it's called true, negative, true, positive, false, negative, false, positive. Okay, so you'll hear this a lot. And what does the first term mean? The first term means if your algorithm classified that point correctly. Okay, so if it's true, what that means is your algorithm classified it as a 0, and the point actually was a 0. Or your algorithm classified it as a 1, and that point actually was a 1. So the first term is going to be whether your algorithm was correct or not. All right, well now the second term, negative, positive. So that is if whatever your algorithm predicted. Okay, so if your algorithm predicted a 0, then it's going to be a negative. If your algorithm predicted that it's a 1, we're going to say positive. So let's go through a couple examples, right? If the actual label is a 1 and your algorithm predicted a 1, okay, so it identified it correctly, it predicted correctly, so true, okay? And now your algorithm predicted that it's a 1, so it's positive. So it's going to be a true positive, okay? Then let's say your algorithm predicted 0, and the actual label is a 1. So the point actually is 1, but your algorithm predicted 0. Okay, so, well, it's false because your algorithm did not predict correctly. But your algorithm predicted what? It predicted a 0. Therefore, it's a negative. So it's a false negative. And that's kind of how you go about doing these things. This one is if your algorithm was correct or not. This one right here is going to be what your algorithm predicted. Either negative is 0, positive 1. Okay. So one of the common examples when talking and explaining about precision and recall is cancer. So we want to be able to predict if a person has cancer or does not have cancer. So let's go through our little terms again, right? Positive is going to mean that they have cancer. Negative is going to mean that they do not have cancer. Okay? So now, let's go and start looking at precision and recall in terms of cancer. So, precision, just definitionally, is this. True positives divided by true positive plus false positive. Recall is true positive divided by true positive plus false negative. Now, if all you're interested in is coming up with the number for precision and recall, that's actually pretty easy. You just plug those numbers into your program, run it, and you'll get your number, and you're off on your merry way, right? But if we want to get a more intuitive understanding of what's actually going on, Okay, well, let's start looking at it and try to figure out if we can come to a better conceptual understanding. All right, so let's think about true positive in terms of cancer, right? This is the number of people who actually have cancer that our model was able to correctly identify. So you look at all of the people who have cancer, and then how many of those people did your model say, yep, he has cancer, yep, he has cancer, yep, he has cancer. Now, if a person did not have cancer and your model said, yep, he had cancer, that doesn't count. That doesn't count in a true positive. True positive is you look at the people who actually have cancer and how many did your model correctly identify out of those people who had cancer. How many did your model pick out from there? That's true positive. That's the number that actually had cancer that were identified. Okay? That's what true positive is. Now, precision and recall both have true positive on the top. So that's what we're kind of interested in. But the denominator is where things get a little bit different. Okay, so precision is the number of true positives plus false positives. And that is the number of positives that my model predicted. Okay? So, what this is, with precision, we are asking in the denominator, how many positives did my model predict? Okay? Did your model say, everything is positive, everyone had cancer, right? That's what we're asking. We are looking at the set that our model predicted. Okay, so we look at what our model predicted and say, out of this, how many did your model say that it was positive? How many did your model say had cancer? Okay? Recall is slightly different. We're not looking at what my model said, how many my model said had cancer. We want to know how many actually had cancer. Okay? Recall, true positive plus false negative. True positive means that they actually had cancer and our model accurately predicted it. And then false negative is kind of the inverse. It says that how many actually had it, but our model predicted incorrectly. Don't know why there was a little thumbs up there, but good. Guess that it's happy about that. Anyways, I don't know why I was doing that. So, precision is going to be out of how many that my model predicted as having cancer. Okay? Precision is how many that my model predicted as having cancer. Recall is out of all of the people who actually had cancer. Okay, so that's how you can just remember that. Precision is how many, it's out of how many that my model said had cancer. Recall is how many people actually had cancer. So now let's go through this and think about it a little bit for which scenarios precision would be useful for and which scenarios recall would be useful for. Okay, so with cancer, if you have cancer, you really want to know about it, right? So which one do we think would be useful for it? Or which metric, which way of measuring my algorithm do you think would be useful if I really want to know that I had cancer if I do? Well, this one, recall, says out of the people who actually have cancer. That sounds like what we want, right? Because we want to know, if I actually have cancer, did I get selected as having cancer? That's what recall is, out of the set of people who actually have cancer. Okay, precision just means that if it's out of the set that my model said has cancer. Okay, that's not exactly what we're looking for. Recall in this scenario seems kind of what we want, right? It is, if I have cancer, does it kind of correctly identify me as having cancer? So what is precision actually good for? Like, if recall is out of how many that actually have cancer, how many it was able to identify, why would we have precision? Well, think about the scenario in the case that my model always predicts cancer, right? It says you have cancer, you have cancer, everyone has cancer, right? Well, what you're going to have is a high recall because out of the people who actually do have cancer, it's going to correctly identify all of them, right? It's going to say you have cancer to everyone. But there's a lot of false alarms. It's going to tell people, hey, you have cancer. Oh no, I have cancer. And oh, actually, I don't. But the model just says that I do. So that's precision. Precision is when you're kind of worried about false alarms, right? You don't want to keep predicting everyone. It's kind of like the boy who cried wolf, right? Like, oh, hey, this bad thing is happening. This bad thing is happening. This bad thing is happening. That's precision is going to start telling you if you're kind of crying wolf. So precision is the boy who cried wolf. And then recall is out of the people who actually have cancer, how many was your model able to correctly identify, right? So these are the two different metrics, and you can start to kind of think about, okay, well, in which scenario should I pay more attention to precision, and in which scenario should I pay more attention to recall? Am I really worried about kind of going too far and saying that everyone has cancer, or am I having some kind of warning system that's always going off, like a fire alarm, right? I don't want my fire alarm to always be going off. That's not very good. So you might be kind of worried about precision in that situation. Or for recall, if it's a really bad sickness and you want to be able to make sure 100% sure that you catch all of the people who actually have it, well, then you're going to be looking at more recall. So that's kind of what these two are about, and gives you a kind of an idea of when to use which one and what they mean. So anyways, hopefully that this video helped you guys out. If it did, please let me know and subscribe, and have a wonderful day. See you.